Current is any motion of charge from one region to another, and we define the current, which is denoted by capital I, to be in the direction in which there is a flow of positive charge. So kung asa dapit ang flow sa positive charge, although we know that electric current is driven by the movement of electrons, we take the direction of the positive charge as the direction of the current. So if the positive charges are moving to the right, though we know that the electrons move to the opposite way, then the current is considered to be or defined to be moving to the right. Mathematically speaking, current is the net charge flowing through the area per unit time, or in formula, I is equal to dq dt. Instantaneous current na siya. It simply means kung pila ang charge nga ni flow per unit of time. Ang unit sa charge is coulombs, while ang sa time is seconds. So therefore, ang current is coulombs per seconds or amperes. 1 ampere is equal to 1 coulomb per second. Ang current nga usual na naga-flow sa TV kay milliamperes, which is equal to 10 to the minus 3 amperes, or could be in terms of microamperes, mu A, which is 10 to the minus 6 amperes. While ang computer circuits is usually nasa nanoamperes, Na, which is equal to 10 to the minus 9 amperes, or in terms of picoamperes, which is 10 to the minus 12 amperes. And naibalaan nato that the current is actually the change in charge per unit change in time, or dq dt. It can also be expressed in terms of N times the absolute value of Q times Vd times A, where N is the concentration, meaning the number of charged particles flowing in an area, while Q is equal to the charge per particle, while Vd is the drift speed, ang ilahang movement speed or drift speed, and ang A is the cross-sectional area of the, let's say usually ang wire, ang cross-sectional area sa wire. And ang kanang concentration is, ang unit ana is per cubic meter, meaning kung pila ka buok charged particles nga naga-move per unit volume. And napod tayo ginatawag nga vector current density, or simply current density denoted by J, which is equal to the concentration times the charge per particle times the drift speed. Wala na tong area. If the Q, or the charge per particle, is positive or greater than 0, then the drift velocity is in the direction as the electric field. While if ang Q is negative or less than 0, then the drift velocity is opposite sa electric field. In either case, positive man or negative man ang charge, current density is in the same direction as the electric field. And ang magnitude sa J, current density, is equal to I over A. Nawala itong A sa NQVD because that A was divided dito sa I, so it became equivalent sa J. So nahimo ng equation is J equals the current I divided by the cross-sectional area, A. So for example, naatay 18 gauge nga copper wire. Muna siyang usually ginagamit sa lamp cords with a diameter of 1.02 millimeters, carries a constant current of 1.67 amperes to a 200 watt lamp. The free electron density in the wire is 8.5 10 to the 28 per cubic meter. Find A, the current density, and B, the drift speed. So for current density, let us look first kung sa mga given kay murag daghan kaayo. Ang kanang 1.02 times 10 to the minus 3 meters mo na siya ang diameter sa copper wire, while 1.67 amperes mo na siyang current. 200 watts, that is, ang watts is a unit of power, pero wala na siya magamit, dili na siya magamit diha. Ang 8.5 times 10 to the 28 per cubic meter, mauna siya ang concentration N. So, for current density, we will use the formula J equals I over A. Ang area is not given, but since it is a wire, we assume it to be a circular, ang cross-sectional area. Lisod kayo na siya, imagine nga rectangle or triangular ang cross-sectional area or square, but usually circular gid na siya, basta wire. And we will use the formula for the area of a circle A equals pi r squared. So compute nato ang area. The radius is half sa diameter, so pi over, or pi times 1.02 times 10 to the minus 3 over 2, because radius, not diameter, is square that. You compute and you get 8.17 times 10 to the minus 7 square meters. So, mao na siya ang atong gamiton sa formula for J. So, J now becomes 1.67 amperes divided by the recently calculated area, 8.17 times 10 to the minus 7 meters squared. And it will give you 2.04 times 10 to the 6 amperes per square meters. Mo na siya ang current density. For drift speed, we will use another formula for J, which is equal to NQVD. Kay mora man na siya ang formula nga na ay VD aside from the current I. I-rearrange nimo ang variables, so naa kay VD equals J over NQ. And we will substitute our values. 2.04 times 10 to the 6 amperes per square meters divided by N, which is 8.5 times 10 to the 28 per cubic meter, times the absolute value of the unit charge sa electron. Constant ni siya, no? Unit charge sa electron, negative 1.60 times 10 to the minus 19 coulombs. And we will get 1.5 times 10 to the minus 4 meters per second. If ato na siyang i-convert into millimeters per second, it becomes 0.15 millimeters per second. So, in every second, ang electron mag-move o gining ana ka, ingana nga kapaspason, 0.15 millimeters. If you multiply that by 60, per minute na akay mga 9 millimeters per minute.